Welcome back, students. This is the session 9 from the playlist of moving charges and magnetism, and the topic for the today's session is BIOT SAVART law. So, on this board, I have written three important points. 3 points लिखे हुए important points हैं, and which is describing this BIOT SAVART law in brief. So, today we will be studying the relation between the current and the magnetic field it produces. That is, whenever a current is flowing in a conductor, it produces a magnetic field around it. First point. Second point is, according to this BIOT SAVART law, the magnetic field due to a current carrying conductor is directly proportional to the current which is flowing through that conductor. It is also directly proportional to the length of the conductor, and it is inversely proportional to the square of the distance of that point from that current carrying element. That is, here I have drawn one simple diagram in which this is a current carrying conductor, and I have taken a very small element. This is a current carrying element which is very small in length. So this point P is the point where we are supposed to find the magnitude of the magnetic field because of this current carrying element. Now the distance of this point P from this current carrying element is R, and this is the displacement vector. Here you can see that at this point I have also drawn one tangent to this current to this infinitesimal element dl, which is given by this dotted line like this. And here theta is the angle which this current carrying element is making with the displacement vector. Okay. Now, so as per this definition, the magnitude of the magnetic field at this point P due to this very small element, this dl, this is the current carrying element which is very small in length. So the magnetic field due to this very small current carrying element dl at this point P will be proportional to the current which is flowing through this conductor, dl, that is the length of this current carrying element, and it will be inversely proportional to the square of the distance of this square of the distance between this point P and this current carrying element. So this is the relation which we have got on the basis of the definition which is written above. Now this equation has been rewritten as mu naught divided by 4 pi I dl sin theta upon r square. Now here what we have done is we have removed this proportionality sign with a constant. Now this constant is mu naught upon 4 pi, where mu naught is the permeability of free space or vacuum, and the value of this mu naught upon 4 pi is 10 to the power minus 7 Tesla meter per ampere. So this is a constant. Sin theta is what? Theta is the angle between this current carrying element, that is the dl, and the displacement vector. Now here you can see here that I have drawn a tangent because this wire is not straight. So what I have done is that I have drawn here a tangent to this current carrying element dl, and theta is the angle which is made by this tangent with this displacement vector. So now from this equation, if theta is equal to 0, that is, if theta is equal to 0, then the magnitude of the magnetic field will be 0, or we can simply say that the magnitude of the magnetic field along the direction of the current is 0. That is, in the direction of the current, the magnitude of this magnetic field due to any current carrying element will be equal to 0. Now, next point is the magnetic field is perpendicular to the plane containing the current element and the displacement vector. So here I have drawn one small diagram. This is the point P which is lying in the xy plane, and this is one conductor which is lying along the y-axis. So I have taken one small this current carrying element dl, and the direction of the current is as shown by this arrow. So as per this definition, the magnetic field due to this current carrying element will be perpendicular to the plane containing the current element and this displacement vector. So the direction of the magnetic field because of this current carrying element at this point P will be along this positive z axis, because the magnetic field is always perpendicular to the plane containing the current element and the displacement vector. So this is all I have for this session. In the next session, I will be taking up a very simple question based on this BIOT SAVART law. That is in the session number 10. I will be coming up with one very simple question which will be based only on this BIOT SAVART law. So till then, have a nice day. Bye.